Have you ever paused for a moment to ponder the world around you? Our everyday lives are filled with captivating phenomena, each with its own story waiting to be unraveled. From the enchanting colors of a sunset to the crackling sound of thunder during a storm, there's a fascinating science behind these seemingly ordinary occurrences. Join us on a journey to explore the mysteries behind the everyday wonders that surround us. Let's begin with a magical experience many of us treasure: watching a sunset. As the sun dips below the horizon, painting the sky with a breathtaking array of colors, have you ever wondered why the sky transforms into a canvas of vibrant oranges, pinks, and purples? The answer lies in a phenomenon known as Rayleigh scattering. When sunlight reaches the Earth's atmosphere, it encounters countless tiny particles such as molecules and dust. These particles scatter light in different directions, but the extent to which they scatter depends on the wavelength of the light. Blue light, with its shorter wavelength, scatters more easily than red light, which has a longer wavelength. During the day, when the sun is directly overhead, the blue light scatters in all directions, filling the sky with a blue hue. However, as the sun begins to set, its light has to travel through a thicker layer of the atmosphere, encountering more particles along the way. This extra distance scatters away most of the blue light, leaving the longer wavelength red, orange, and pink light to reach our eyes. And thus, we witness the mesmerizing beauty of a sunset. Now, let's shift our attention to a phenomenon that we often experience in our everyday lives: static electricity. Have you ever noticed how your hair stands on end when you touch a Van de Graaff generator or when you remove a woolen sweater on a dry day? This peculiar occurrence can be attributed to the imbalance of electric charge. Objects, such as the Van de Graaff generator or your body, can accumulate electric charge through various means. When you touch a charged object, like the generator, the excess electrons move from the object to your body or vice versa. This transfer of electrons creates an imbalance, resulting in the buildup of static electricity. The reason your hair stands up is due to the principle of electric repulsion. Each strand of hair carries a negative charge, and like charges repel each other. As the excess electrons gather along the strands, they repel one another, causing your hair to stand on end. But static electricity isn't limited to hair-raising experiences. It also plays a significant role in the formation of lightning during thunderstorms. As clouds move through the atmosphere, they gather static charge through a complex process called triboelectric charging. When these charged clouds approach the ground or other clouds with opposite charges, a dramatic discharge occurs, resulting in the spectacular phenomenon we know as lightning. Now, let's venture into the realm of sound and explore the thunderous rumble that accompanies a thunderstorm. When lightning bolts streak across the sky, they generate an enormous amount of heat in the surrounding air. In fact, the temperature can rise as high as 30,000 degrees Celsius or 54,000 degrees Fahrenheit in a split second. This intense heat causes the air molecules in the lightning's path to vibrate rapidly. These vibrations propagate as a shockwave through the atmosphere, creating a compression of air particles. As the shockwave reaches our ears, we perceive it as the loud and booming sound we call thunder. The reason we hear thunder after we see lightning is due to the difference in the speed of light and sound. Light travels at an astonishing speed of approximately 300,000 kilometers, or 186,000 miles per second, while sound travels much slower at about 343 meters or 1,125 feet per second. Since light travels significantly faster than sound, we see the flash of lightning almost instantaneously, while the sound takes a bit longer to reach us. By counting the seconds between the flash of lightning and the rumble of thunder, we can estimate the distance of the storm. Sound travels roughly 1 kilometer or 0.6 miles every 3 seconds, so if we count 5 seconds, for example, the storm is approximately 1.5 kilometers or 0.9 miles away. These are just a few examples of the science behind everyday phenomena that we often take for granted. From the captivating colors of a sunset to the crackling sound of thunder, our world is a treasure trove of scientific wonders. But why does understanding the science behind these phenomena matter? Well, for one, it allows us to appreciate the world around us on a deeper level. Knowing the scientific explanations behind everyday occurrences adds a sense of wonder and curiosity to our daily lives. Furthermore, understanding the science behind these phenomena can have practical applications. It forms the foundation for various fields of study, such as meteorology, physics, and atmospheric science. By unraveling the mysteries behind these phenomena, scientists can develop better models to predict weather patterns, enhance our understanding of the Earth's atmosphere, and even improve technologies like lightning protection systems. So, the next time you witness a captivating sunset or hear the mighty roar of thunder, take a moment to reflect on the intricate scientific processes unfolding before your eyes and ears. Embrace the wonders of our world and let the science behind everyday phenomena ignite your curiosity. In conclusion, the science behind everyday phenomena is both fascinating and essential. From the scattering of light that creates colorful sunsets to the dance of electrons that produces static electricity, and the reverberating shockwaves that form thunder, the world around us is a stage for scientific wonders. By delving into the explanations behind these phenomena, we gain a deeper appreciation for the intricacies of our universe and the laws that govern it. So, let us embark on this awe-inspiring journey of discovery, where even the simplest of everyday phenomena can reveal extraordinary scientific truths.
I can hear the footsteps from afar, drawing near until it hit my heart. Heard a knock, so I went to